Lecture 4, Setting up HashiCorp Vault on AWS. First, you'll want to retrieve the vault-config.txt from the external resources in the lecture and rename it to vault-config.hcl. HCL is a HashiCorp language used primarily for all HashiCorp products, which include both HashiCorp Vault and HashiCorp Terraform. Edit it to replace the region and table values. Next, you'll retrieve vault-unseal.txt from external resources in the lecture and rename it to vault-unseal.sh. This will be the script that you run to unseal the vault every time the autoscaling group is deployed. That includes scaling up or scaling down. Upload vault-config.hcl, vault-unseal.sh to your S3 bucket created in Lecture 3, the previous lecture. Next, you want to create a Route 53 record set using an alias to point to the elastic load balancer created in Lecture 3. For example, vault.troydieter.com, which would include an alias record to point to my elastic load balancer. That elastic load balancer would then reference the target group in your autoscaling group. Wait until the record set propagates, then browse to the record set. For example, https vault.troydieter.com. You will be forwarded to the ELB, in which you'll be prompted to set up and initialize the vault. If you have any issues, feel free to ask in the questions and answer section or go back to the previous lecture. You'll want to ensure that vault-unseal.sh is set correctly, which will be the script that essentially runs every time the autoscaling group is created or destroyed. If you're continuing to have issues, try scaling down the autoscaling group and then scaling it back up. By setting it to 0, then back to 1, will surely enable that it will reference the S3 bucket for the new files. First steps you'll see on the initialization of the vault will be asking you to create the key share value and the key threshold. This is essentially how many signers you need to unseal the vault every time. You'll want to set that vault in this example to key shares 1 with a key threshold of 1. This means that it's only one key is required to unseal the vault. It's going to provide you the initial root token and the key. Make sure you document both those values in a safe place. After that step, it'll show vault is unsealed. Use that vault unseal key in the key section to unseal the vault. It will unseal the vault and then enter that root token that was provided after you initially configured it that I told you to store, and that will allow you to sign in. Next, you'll want to create a file named payload.json and paste it in the key 1 value you initialize the vault with. And next, you'll have the contents of payload.json, which will include bracket open, key, your pasted key value, and close. So this essentially, your pasted key value will be the unseal token value that you retrieved while setting up the vault. Upload payload.json to the S3 bucket created in Lecture 3. You'll want to set encryption on this as well if you'd like. Now use the user data init script defined in the EC2 launch configuration, which will automatically unseal the vault and mark it as healthy, which is the 200 status code for the ELB. Essentially, the process goes: autoscaling group increases desired capacity, launches the launch configuration you created in Lecture 3, user data uses vault-unseal.sh to retrieve payload.json, which is using the attached EC2 role so it can retrieve from the S3 bucket. The vault automatically unseals and marks the HTTP header 200 for ELB. Users can now log into the vault or use API pull requests. In the next lecture, we'll cover the AWS Secrets Engine configuration. Come join me. Thanks.